Your lesson today is on square and cube roots, and the goal is to simplify expressions involving square and cube roots. I want to let you know that this lesson is being recorded from my home without a smartboard, so when I write some things up, it may take a little longer than usual. So feel free to fast forward along as I'll be saying what I'm going to write, but I'll be saying it a lot faster. We start with square roots. So right here we have a radical sign. It represents the positive square root of a number. A radical expression involves the radical sign. And a perfect square is the term we use for a number that has integer square roots. So it is very, very helpful if you can memorize the first 15 perfect squares. These are kind of like those basic addition, multiplication, facts, etc. that you just know. First 15 perfect squares, it'd be great if you just knew them. And here they are. 1, which is 1 times 1, 4, which is 2 times 2, 9, which is 3 times 3, 16, 4 times 4, etc. All the way up through 225. So we're going to be estimating square roots because not all roots are perfect. So we're going to estimate the square root of 43. If you recall from the previous slide, it is not one of our first 15 perfect squares. So some estimation is involved. We start by determining which two perfect squares the number under the radical sign falls between. So referring back to your list on the previous page, we know that it falls between 36, here's where it takes a little while, and 49. The next step we need to do is determine to which of these perfect squares the number under the radical sign is closest to. And just some simple counting tells us it is closer to 49. So finally, the square root of the number we found in step 2 is the estimated answer. So the square root of 49 is 7. So we're just going to estimate that the square root of 43 is 7. Remember, guys, estimates aren't going to be perfect. So it's not 7, but it's pretty close to 7, at least closer than it is to 6. So that is our answer for this question. So let's practice that with these following 3 examples. Now, if you would like to stop the video and try on your own, please feel free to. If you're not quite sure yet, you want to watch me do a couple examples, that's fine, or even one example before you try your own. But however you want to do this, this is your pace. So, radical 58, it falls between 49 and 64. Those are the two perfect squares that it falls between. This is not going as slow as I thought it would. So 58, the number under the radical sign, is closer to 64. And radical 64 is 8. Not the easiest number to draw without a pen, just a mouse, but that's not bad. So 8 would be our final answer. Radical 110. So 110 falls between 100 and 121. And just from counting, we can tell that 110 is closer to 100, which means the square root we're going to estimate is 10. Finally, radical 182. 182 falls between the perfect squares of 169 and 196. And 182 is closer to 169. Therefore, we can estimate the square root of 182. Estimated is 13 because it's close. That's radical 169. I promise you, my handwriting, guys, is much better when I'm actually standing by the smartboard. This is mouse writing, which, all things considered, is not that bad. Now, on to cube roots. So square roots was kind of the opposite of squaring a number. Cube roots, well, it's the opposite of cubing a number. Cubing a number is when we raise it to the third power. So to find the cube root, just go the other way. Kind of the best way I can describe it to you. So 3 cubed, or 3 to the third power, is 27, because 3 times 3 times 3 is 27. So the cube root of 27 is 3. And then the cube root symbol looks like that's a radical sign with a little 3 kind of inside that check mark. So therefore we say the cube root of 27 is 3. That's the way that is read. And kind of like the first 15 perfect squares, it's good to know the first 10 perfect cubes or cube roots. So the cube root is 1. So 1 to the third power, which means 1 times 1 times 1 is 1. If you guys want to try to fill the chart out, by the way, on your own, go ahead or stay with me. 2 cubed is 8. We just did 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. First 5 aren't that hard to memorize. Pen's pretty easy too. I've been 6, 7, 8, 9. A little bit of thinking here. 6 times 6 times 6 is 216. 7 times 7 times 7 is going to be 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. Then 10 times 10 times 10, 10 to the third power, just means we have 3 zeros there, so it's 1,000. Again, really, really good to memorize. As you guys get deeper into math, you will see why this is a really good foundation to have. This concludes your lesson over square and cube roots.